Hello friends and welcome to another tutorial. In this tutorial I will show you how you can define a function that will calculate the respiratory rate or say number of breaths per minute. The logic is that we will upsample the detected RR intervals using cubic spline interpolation. I have already explained the spline interpolation, how it is coded. So if you haven't watched that video, the link will be in the description. And then we will apply a threshold at minimum 6 and maximum 24 breaths per minute, and at the end we will extract the respiratory rate from the signal. There are different methods to calculate the respiratory rate. You can use FFT or fast Fourier transform, welch filter or periodogram. The spline interpolation, welch filter and periodogram are already available in the scipy library and NumPy library, so I will use them. So first of all, we will do spline interpolation. So for spline interpolation we will need dependent and independent variable and then degree of freedom. So independent variable will be the RR intervals, while dependent variable, for dependent variable we are making a list that will have an equidistant point between 0 to length of the RR intervals, and number of points in between this start and stop will also be the length of RR interval. So for example, if we have 20 RR intervals, so the dependent variable will have 20 points and the value of those 20 points will be in between 0 and 20. So let's define the interpolation function. K will be equals to 3 because we are going to use cubic spline interpolation. So this interpolation is applied on a new data. So let's define the new data. Because we are interpolating, so the list will be long, and how many points should be in the list is defined by the sum value of all the RR intervals. So let's apply this interpolation. This interpolated data will be our breathing signal, so I can say. Then we have to apply the thresholding to limit the breathing rate between 6 and 24 breaths per minute. For that I will use the filtering function that I have already defined. The link to the filter signal function will also be in the description. As we have interpolated the data, so this will also change the sampling frequency. So using the cubic spline interpolation, the sampling frequency is upsampled by 10 times. So the new sampling frequency will be, let's ask the user to enter the sampling rate as well. We will keep the sampling rate at 100 initially, but user can enter it. So after the filtration we have to extract the respiratory rate or breathing rate. So for FFT we have to input sampling frequency and then apply the fast Fourier transform on the data. So first let us define the sampling frequency for fast Fourier transform. This d value is the reciprocal of sampling frequency, so then we will take only the positive frequencies. So let us calculate the power spectrum density, because the value of power spectrum density will be used to extract the respiratory rate. And power spectrum density is the twice absolute value of fast Fourier transform. Then if the method is welch, so the welch function returns frequency and power spectrum density. N per segment means the length of the segment, which will always be equals to the length of the filtered breathing signal. Similarly, if the calculation method is a periodogram, this function also returns frequency and PST. We can notify the user if they have mentioned any different calculation method. So as while calling this function I have entered, you have to mention the measurement dictionary as well as the data dictionary. Let us update the measurement dictionary. So the respiratory rate will be the value of the frequency where power spectrum density is maximum. Remember, this is frequency, so it is in hertz. To convert it into breaths per minute, you have to multiply it by 60. Let us also update the data dictionary. And at the end of the function, we have to return this dictionary. So this is how you can define a function that will calculate the respiratory rate. So let us run an example and see how it works. So first of all, we have to calculate the RR interval. I will be using this function which I have already defined. So let's calculate the respiratory rate. Sorry, when I was calling this filter function, I put double T here. So save this and re-import and run the example. And also this here, it should not be length, it should be integer. Okay, so resave, re-import and run this. So now you can see that we have calculated our respiratory rate, and so this is showing that 0.17 in the frequency, while when I multiply it with 60, so it will give me respiratory rate 10.24. So I hope you have learned something new. If you like this video, please hit like, share, and do comment that how I can improve my videos or any suggestions you have. Please subscribe to my channel. Thank you.